Children, so next we can discuss another important concept, that is radius of gyration. So what do you mean by radius of gyration? Radius of gyration of a body about an axis may be defined as the distance from the axis of a point whose mass is equal to mass of the whole body and whose moment of inertia is equal to moment of inertia of the body about the axis. I know you won't understand anything from this definition. So first let's discuss how to find out this radius of gyration. Radius of gyration is a distance itself, and how to find out that distance. So for that, consider a rigid body and consider an axis of rotation, let it be AB. First step is to find out the center of mass of the rigid body. Find the center of mass. And center of mass, this is the center of mass. Let this point be the center of mass of the rigid body. Okay. So on the center of mass, the whole mass is concentrated. Now, let's find out a distance of the center of mass from the axis such that the moment of inertia of the center of mass is equal to total moment of inertia of the rigid body. Children, I repeat, we must assume a distance of this center of mass from the axis of rotation such that the moment of inertia of rigid body is equal to moment of inertia of this center of mass. Okay, so second is to find a suitable distance such that the moment of inertia of the center of mass is equal to total moment of inertia of the rigid body. Then this distance can be considered as radius of gyration. Okay, the distance of center of mass from the axis of rotation is called radius of gyration. It is the practical This is the equation to find out radius of gyration. I is equal to mk square, where k is the radius of gyration. K is the distance of the center of mass from the axis of rotation. Okay, so that is what is explained in this derivation. The radius of gyration may be defined as the distance from the axis of a mass point. Mass point means our center of mass, whose mass is equal to mass of the whole body. So that mass point is our center of mass, because mass is the whole mass, or the mass of whole body is concentrated at that mass point. And whose moment of inertia, that means the moment of inertia of that center of mass, must be equal to moment of inertia of the body about the axis. Okay. Now here you can see the table, and on the table the moment of inertia equations to find out and here is a table which shows the moment of inertia of different shapes. So for a thin circular ring of radius r, this is the ring. What is the moment of inertia? Moment of inertia is mr square, where r is the radius of that ring. Okay, for a thin circular ring which is rotating about an axis perpendicular to its plane, and also the axis should pass through the center of that ring. Okay, here you can see a ring, and this ring is rotating about the axis. This axis is passing through its center, and also this axis is perpendicular to the ring. Okay, so for a thin circular ring which is rotating about an axis perpendicular to its plane and also passing through the center, moment of inertia is mr square, where r is the radius of the ring. And for a circular disc of radius r which is rotating about an axis perpendicular to its plane and also passing through the center, moment of inertia is mr square by 2, where r is the radius of that disc. And for a thin rod of length capital L which is rotating about an axis perpendicular to its rod, this is the axis, and at the center, moment of inertia is 1 by 12 ml square, where L is the length of the rod. And for a solid sphere of radius r which is rotating about its diameter, so here it is rotating about its diameter. So moment of inertia of the ring about its diameter is 2 by 5 mr square, where r is the radius. Then hollow cylinder. For a hollow cylinder of radius r like this, which is rotating about an axis like this, the moment of inertia is mr square. Then for a thin circular ring which is rotating about the diameter, moment of inertia is 1 by 2 mr square. For a circular disc which is rotating about the diameter, moment of inertia is 1 by 4 mr square. For a thin rod of length L perpendicular to the rod at end point, here the axis is not passing through the center of the rod, here the axis is passing through one end of the rod, moment of inertia is 1 by 3 ml square. And for a plate of length L and width W perpendicular to the plate and at the center like this, if this plate is rotating about this axis, the moment of inertia is 1 by 12 into m into L square plus W square, where L is the length and W is the width of the plate. For a solid cylinder of radius r which is rotating about an axis passing through its center, moment of inertia is 1 by 2 mr square. So you must note down the moment of inertia equations for these different shapes, because these shapes are rotating about different axes, and the moment of inertia for all these shapes rotating about different axes of rotation will be different. So you must note down, and I don't know whether it is there in your reference books. So for your convenience, you can tabulate all these things and you can study it by heart. You can by heart the moment of inertia equations of all the shapes. So it will be easy for you to solve the problems. Okay, so take a screenshot and note down the table. Two tables are there in 2 slides. So take the screenshot of these 2 tables and just note down. Okay. So with this, I am concluding my session. Notes of the topic and YouTube video have been uploaded. Just go through it. We will meet in the next session. Till then, take care all of you. Stay home, stay safe, keep learning. Thank you.